Good morning, teacher. We are the fifth group, and I will start now. The authors of this article talks about the importance of thermal modeling in carbon dioxide storage. Introduction. In the last years, some industries produces carbon dioxide so much, but it's not good for the nature. And also some industries recommend the decarbonization. Um, One of the technologies of this process is the capture carbon and storage. What is carbon capture and storage? And okay, that consists of inject carbon dioxide in a reservoir. Obviously, this affects the temperature of reservoir. How does the temperature affect? Okay, initially, when we want to inject carbon dioxide into the reservoir, first we carry in the carbon dioxide from the surface, from the industries, to obviously it is separated, traded, and transported to the reservoir. And when we inject into the reservoir, it changes the temperature of the reservoir, and it changes storage capacity. Okay, there are some reasons for these temperature changes. One of the reasons is the Joule-Thomson effect. That consists to when we inject carbon dioxide into the reservoir, it expands and it change that and it cools the rock, the seal rock, and it cools the seal rock. Other reason it is the most obviously is the differences of temperature in the reservoir and the temperature of the carbon dioxide. Okay, another reason is the geothermal effects. Um, when we inject carbon dioxide into the reservoir, it moves through the reservoir, and the temperature increases or decreases as you go deeper into the reservoir. And reason number 4 is the carbon dioxide migration. When the carbon dioxide moves in through the reservoir, it will arrive in a final place of storage, and this changes the when the well the the these changes can affect the properties of rock and fluids. Yes. Okay, case study. The authors of these articles were based on a reservoir in Malaysia, specifically in Luconia. And in this slide, we can see some properties of the reservoir. One of the properties is porosity. The porosity is between 15% to 25%, and the permeability is between 400 to 600 millidarcies. And these reservoirs have 1.8 billion cubic feet of cast initially in place, and with a recovery factor of 80%. And yes, one more consideration of this case study is the reservoir that is place of this study is a platform type carbonate built-up reservoir and with a four-way deep closure. Other consideration is that in this study they used a two-way coupled dynamic geomechanical modeling and was performed to capture the geomechanical changes using a compositional simulation and in a corner point mesh. Results: the comparison of the coupled thermal modeling. Oh, sorry. The comparison of the results of two-way coupled modeling and thermal modeling shows differences in the results during and after carbon dioxide injection. Cooling by carbon dioxide injection reduces the fracture gradient of the reservoir and the sealed rock. Okay, in the thermal model, a reduction up to 1,400 psi. This was observed at a reservoir fracture gradient and 700 psi in the sealed rock. This affects the maximum sealed rock injection pressure limit, which differs by approximately 110 psi between both models. Okay, this difference in injection pressure limit results in a 10% reduction in the maximum estimated storage capacity. Okay. Yes. Considerations to take into account. The authors of this article don't provide specific details in a geomechanical in geological formations optimal for carbon dioxide storage. Okay, they don't provide this, and also they don't provide equations for state used in this simulation, and they don't provide a time for this simulation, and etc. While it mentions that storage is mainly in sedimentary basins with at least 1,000 meters thickness and suitable rocks. And complete understanding and accurate estimates require addressing the emissions and considering the specific geological and detailed behavior of the carbon dioxide fluid in simulation models. Conclusions. Okay, this process, the carbon capture and storage, is very important for the climate changes in the last years. Yes, this is a not simple process. No, we don't only inject the carbon dioxide into the reservoir and that it's all. No, it is a complex process. Well, for example, in the thermal modeling, it's essential to understand the potential reduction in seal fracture gradient. and storage capacity estimated using the thermal model. And this case study is approximately 10%, yes, 10%, that of the bidirectional couple model due to approximately 110 psi, or injection pressure limit due to cooling. Yes, and that is when we want to make a carbon capture and storage, we need to do a complex process. First, modeling a reservoir for for we want to view the changes of temperature in various zones of the reservoir. Okay, and that is all. Thank you so much for hearing or for listening to me, for listening to our exposition, and I'm very excited to do this. Thank you.